Okay, hello guys. So today our topic is about thermal phases and we are learning about the first part of this, okay? And here is the content you can find here. The first part is moving particles and temperature. Second part is about temperature. And the third part is about heating gases. And the last part is about three ways of transfer heat. So we have two perspectives of the thermal phases. The first part is you're using your daily life view in the daily world, like you're using the temperature, using the volume, using the pressure to describe a kind of substance or kind of gases. Okay, this is the first perspective. And second perspective is you're using the like atoms view or like a molecules view. Okay, this is the third perspective we can learn in the physics. Okay, so here in the first part we are using the like a particles view or the molecules view about the temperature. Okay, so let's move into the first part about moving particles in the solid. Okay, so here you can find in the figure that there are many small balls in the solid, right? Here we can say that the small balls are like the particles. They're maybe atoms or they're maybe the molecules. They're just the very basic method to combine an object. Okay. So here we knew that there are the small particles. We can say that they're combined together and becomes a solid, right? And here in the figure, we can find three conclusions for the figure. So in the solid, we can find they're very closely to each other, right? And they're very have a regular arrangement, right? So the first conclusion is that they are very regularly arrangement. Okay, so this is a first property for the solid. Okay, you can find that they have arranged in a column and like in like in different columns and different like rows, right? So this is first they have a very regularly arrangement, and the second reason is that you can find here inside of this they are very close to each other, right? They are very close to each other. So that is because you can find in the particles they're combined very tightly and like very close. And this makes their density sometimes very high rather than the liquid and the gases, okay? So they are very close to each other. And the third part is that, or the third conclusion is that you can find here, why they have a very stable state. Like if you're in the daily life, you can like using ice, using metal, using steel, like or something. They're very stable and very strong or very hard, right? That is because inside of it, they have a very strong like a structure. Okay. So here, each particles cannot fly or like cannot have a free motion. That is because they want to like build a very strong structure. Okay. So here we can say inside of these molecules, they can only vibrate at its fixed place. Okay. Vibrate at fixed place. Okay, and there's no free motion inside of this. Okay, so this is about the moving particles in solid. Okay, and the second part is about moving particles in liquid, and you can find in the figure. And here are many atoms inside of this, and maybe trying to vibrate at every places, right? Maybe it's not doesn't have a vibrate because they have a many gaps between them. So maybe from the liquid they start to have a free motion. Okay, so we can also have three conclusions for this. The first conclusion is that maybe their arrangement now is not regular, right? Because here you can find their randomly arrangement. Okay, so here the first property is that they are randomly arrangement. Okay, so this is the first property. Okay, and for the second property, we can say that you can find inside of the molecules they have gaps, right? Maybe they're not combined very tightly. Okay, so they have a maybe start to have a distance between each molecules or each small balls. And the third properties you can see here inside of this, maybe here you can find many small balls inside of this, and they start to have a little bit of motion. So here we can say that it has, or it starts to have a little bit free motion. Okay. So there are three properties inside of the liquid we can find here. Okay. First, second, and third. Okay. And after that, you can move into the gases part. Okay. So here in the gases, we can set inside of the gases, they are starting to have a like a very free motion, right? So they also can, we can describe the figure into three parts. The first conclusion is that maybe here they are very like randomly arrangement, the same as the liquid, maybe more than the liquid, right? Randomly arrangement. And also you can find each molecules or each ball's distance are very far apart from each other. So we can say that here inside of the gases, they have a very long distance between each other, right? The distance between the molecules is bigger and bigger, right? And the third property or the third conclusion is that inside of the gases, we can say that here they have a very fast speed and they have a totally random motion. Okay, there are the three properties in the gases. Okay, and here after we discuss about the three properties and three states of the object, let's move into the Brownian motion, the next part. Okay, so what is for Brownian motion? And maybe you can see some videos in like in the slide. Maybe this time we have not enough time. Maybe next time you will learn about the Brownian motion or see the Brownian motion's video. Okay, so for Brownian motion, it's just we are putting some like the flower pollens inside of the water. And in the beaker, you can find many flower pollens just moving around randomly. Like here, you can put in some flower pollen inside of this, and you find pollen first move to this place, and next time it moves to this place, and next second to this place. Just a random motion, doesn't have any like conclusion for us. Okay, so we can say why is this? Why the pollen can have a random motion? So before this, you have to learn about two new words: the difference between the particles and the molecules, or you can say particles versus molecules. Okay, so for particles and molecules, first we can have the first conclusion for this. So for particles, we can say that inside of this, maybe it's a like a very big, a small ball. Okay, a very big ball like here. You can see by your eyes, but it's very hard for you to see them. Okay, so we can say particles are very hard to see them. Okay, so like in your daily life, if you're in the afternoon, you sit in your classroom and you'll find that there are many small, tiny, the dust floating in the air, right? So we can say that the dust, although it's very small, but we can see them very directly. Okay, so here there are the particles. This is the first properties for this. And secondly, we can say that maybe the particles are just like some like the pollens, like some very mist, some very density mist, like in the air mist. So you can just see them directly, okay? But very hard. Sometimes you cannot see them when you are not focusing on them, okay? So they are very hard to see them. But molecules means that they are invisible. Like so water molecules, you cannot see directly into the water, right? Because they are just liquid. You cannot find there are many small balls inside of this, right? They are just our imagination for IGCSE physics. Maybe in the future, when you learn about something about the microscope or high advanced microscope, you can see them directly. Okay, but now you're just imagine the small balls inside of the liquid. Okay, so here we can say that molecules are invisible or they have a invisibility. Okay, so here is for Brownian motion. Okay, and for the second part, we can say that for the Brownian motion, once we have the particles and we have the molecules, and for Brownian motions, you can imagine the pollens like a very huge person in the railway or in the train, right? And if you already take the subway, maybe you can find here, like some subways maybe in Indonesia or like in China or like in other places or like in London. If you're taking the subway, you can find when we are going to work like 8 a.m. or like 9 a.m. or we are back to home at 4 p.m. or like 5 p.m. There are a crowd of people inside of the railway, right? And if you take the subway, you can find, although maybe the person in the middle is very big, but like there are a crowd of people inside of the subway. You can find many people are standing here. Okay, and once the subway starts to have a motion, you can find each molecules or each like the passengers just have a motion with the train, right? So here you can find in the middle, although the particles is very big, or it's like a passenger, it's like a very big passenger, and it is just moved by other passengers, right? Because the probably people gives you a force, and you start like falling down to the ground, right? This way. So we can say that for the Brownian motion, we can just imagine as this model that the very big passengers are moved by other small passengers as a subway to start to have a motion. Okay. So here we can describe that for this reason, that we cannot move or particles cannot move by themselves. Okay, so they're just moved by the small passengers beside it. Okay, so we can say that in the Brownian motion experiment, we can say that the middle atoms or like middle particles are moved by the small molecules. So this proves that the small molecules have a motion. Okay, so this is for the difference between the particles and molecules and how molecules can move the particles. Okay, so this proves that water molecules have a free motion and they are randomly. Okay, because when you observe the pollens, you can find they just also have a random motion. That's because different water molecules gives it a very random force. Like sometimes it's moving upwards, and sometimes moving right, and sometimes moving left, and moving downwards like this way. Okay, so this is for Brownian motion. Okay. And then we have to introduce, I have to introduce you two energies that is called kinetic energy and potential energy. We have learned before, right? And for kinetic energy, we can say that it is an energy because of the motion. And in the molecules, we can say that when temperature of the molecules increases, their average velocity, remember that here is average, not the velocity, okay? Average velocity of the molecules also increases. So we can say that when temperature increases, there are a lot kinetic energy inside of the bodies, okay? So here is for this property for the particles. And second is about the potential energy. I said the potential energy means like the changing position or change the shape of the object. Or maybe sometimes in substance you are fine here, if you are changing the state, like you're changing from solid to liquid to gases, like when the solid is melting, like ice is melting, so it is needs heat and it's like needs to get the temperature and it will absorb heat, okay, like this way. So right here you can find, although the temperature doesn't change because temperature remains at 0 degree, right? But its energy or total energy increases. That is because inside of this, the solid particles, like they are changing the another state into the liquid particles. Their position change. That means their energy or their potential energy just change. So there, because potential energy increases. Okay, so this is why we said that solid into liquid total energy increase. But this is not because for kinetic, because temperature doesn't change, but it's for potential energy. Okay, the position and the relative motion makes the potential energy changes. Okay, so let's move into the next question for our today's lesson. Okay, here you can find what is the answer for this problem and try to solve it, please. Okay, so I guess you have your answer. Okay, let's move into the problem. I said that a student uses a microscope to observe the pollen moving on the surface of the water, right? And we say when describe the reason for the movement. Okay, so first you can find in A, B, C, and D, here are different description about molecules and the particles, right? So for water molecules, you can find here, water molecules just using like we said that it's invisibility, right? They have invisibility and they are invisible. So water molecules is correct. But if you describe like the water particles, it's not correct. Okay. And here for pollen, we can say pollen is a particle, right? And we cannot using the pollen molecules, right? So here you can find B is not correct because it's a pollen molecules. There are two very distinct words. Okay. And you can find in the D, pollen molecules, also you are using the molecules, right? They are not correct. And we said that water molecules are very small, like in the subway, like the pollens is very big, but it's surrounded by many, many water molecules, right? Okay, so this is because it moved by the water molecules. So only here we can choose the C as our final answer, okay? So here is the problem we're choosing C, okay? So here, can you understand the problem? Okay, so this is for today's our lesson, okay? See you next time. Bye.